So the second part of our exercise is about Java data types. So now we create a new class with the name primitive data types and literals. Since I already have one, I name it number 2. So you see once again that we are using here upper camel case. All the words are written together, and every word and the first one is starting with the capital letter. We press here finish, and this is our class. So Java data types. There are a lot of them, and let us discuss in detail the main types of primitive data types. So first, primitive data types. So the very first variable is a variable of byte data type. So let us name it byte variable. And let's assign it the value 127. So as you have learned, the byte variables, when you declare a byte variable, the Java will automatically allocate specific part of memory with a size of 8-bit to the variable byte variable. It means that this variable can vary from -128 to 127 inclusive. It means that if, for example, we want to have this variable with a value 128, we will have an error that tells us that this is not appropriate weight, and maybe you want to change your type to integer. So we leave it as 127. The advantage of using a byte variable is that you can save memory. Especially it is important in large arrays. If you know in advance that the values inside of arrays will not be less than -128 or higher than 127, then you are encouraged to use byte variable. The next one is short type, and we will name the variable short variable. And as we know, this variable can vary from -32,768 to +32,767. So it means that we can assign, for example, a value, the lowest boundary value, and this will be okay. If we will select a variable that is, just a second, another direction here, then we'll receive immediately an error. That's why we leave it with 8 at the end. The motivation to use the short variable type is the same as with byte. If we know that the variable will be in the range that is acceptable for the short variable, then we use this data type. The standard, or maybe not standard, but most often used data type is integer. And in order to declare integer variable, we use the keyword int, and int variable is the name of our variable. This can be, for example, 1 million. Yeah. This is the value of a variable. This variable has a size of 32-bit. Next variable is the variable of type long. And long variable can be pretty high, can have pretty high value of the variable, and at the end we put the letter L, specifying that this is a long variable. The size that is allocated, the part of the memory that is allocated to this variable is of the size 64-bit. The next variable type is float. Float variable. And this is the variable that can have some floating point. Let us say this one, and we put f at the end, specifying that this is a float variable. There is another variable with a floating point. This is double. I will explain the difference between them in a second. Yeah, let us take the same value. So the default choice for variables with decimal points is double variable. This is a default choice. However, if the memory size is important for you and you want to save memory in large arrays, then it is advised to use float variable. The next type is Boolean variable. That is a variable that can have only two values, true or false. If you write, for example, as another programming language in capital, it will not be recognized by Java, so you need to write it in small letters. The next variable is character variable. And the character variable can have only one character, and this is you can also use here a great variety of Unicode characters. And there are specific conventions that you need to use, like there are codes that you just put here inside to show those variables, for example, show those values. For example, if you want to have euro euro sign, then you are using the following code. When you will execute the code with this variable, then you will receive a euro sign. So now we have an overview of all our variables. So now, to enhance the understanding of how and when to select which data type, let us draw the following picture. So let us imagine one pretty artificial case that we have a memory of size of 64-bit. So let us divide it into pieces. So here we have 32, here 16. So now we have 8-bit pieces. So this is a memory of 64-bit. So we have several types of variable. And we have the number of variables that can be allocated of the specific type. So, for example, if we select a variable of type byte that has size of 8-bit, then we can use our memory to allocate here 8 variables of the size of the data type byte. If we have, let us select another color. If we have short variable that needs 16-bit of your memory, then you can allocate here 4 such variables. If you decide for integer that is of the size 32 bits, then you can take 1, 2 pieces of the memory and you're allocating 2 variables. And if you decide to use long variable that needs 64-bit, then of course you are using the whole memory with only 1 variable. So this example shows you why is it important to select the appropriate type of the variable if the memory allocation is a concern. Especially you need to think about it if you will have large arrays in your Java program. So the next interesting topic are operators. And for this purpose we will create a new class that is called operators. So since we want to print the results to the console, we will have our main method, public static void main string args and curly brackets. So first we will have a look on arithmetic operators. let us say that we have a variable of the type integer, variable a, and this variable should tell us the result of the operation 4 plus 4. So to see the result, we write our system out print line statement, and we just put here a. And we see the result 8. We have now we have just executed the program with our shortcut. So I will now just write the several examples of operators. Maybe I will just copy them to save our time. So here we have plus, minus, times, division, and modulo operators. And we want to print them all here, and we want to print them, and each one should start with new line. That's why we are using now \n. I will copy this to save our time. And we are running the program, and we see the results. So the result of the first operation is 8, 8, 10, 4, and 1 is the result of the modulo operation. The next type of operators are assignment operators. So let us say that we have variable a that has a value 20. The assignment operators, they provide us the possibility to shortcut some specific operators. Like the very first operator is of course assignment as itself, and the next what we can do, we can add. So if we would like to add let us say 2 to our variable a, the very first option would be variable a is equals to variable a plus 2, and we want to print the result to our console. Variable a. So first I will comment out another print line statements so that we have only relevant ones. So first let us print the result of the first operation, this one. Of course it should be just written in this way. We don't want to print the word itself. 20, you see here 20. So if we want to add 2, we add it in this way and we have 22. If you want to use a shortcut, then you write it in the following way: plus 2. And you have again 22. There are a lot of other assignment operators. For example, variable a minus equal to 4. And if we now execute our program, you will see that the value of the variable has changed. There are other assignment operators that we could use. For example, all these ones. If we execute the program one line after another, commenting out the following lines, then we would every time receive different values, that the current values of our variable a, and this is the very last value of this variable after the last operation, the last statement. The next type of operators are bitwise operators. So let us say we have two integer variables, variable f with value 5 and integer variable g with value 7. The first is bitwise AND. So the bitwise AND we want to print it directly to console, system out, print line. So what we want to print here, we want to print the result of the bitwise operation f and g, and we want to see the result that should be the operation f and g. We will comment out the previous print line statement. So we see f and g, and this is what we have written here, is equals to 5, the result of this bitwise operation. So there are also following bitwise operations that I will just copy here. So the next one is bitwise OR. That looks in this way, f or g, and the result is 7. Next, bitwise exclusive OR. And here is the result, 2. Unary, bitwise inverse, and we want to have the inverse of f, and it is -6. So the next bitwise operators are shift operators, and there are several of them. So the first one is left shift operator. Here, exactly here we miss one bracket. We have to define, yeah, that's true. We want to have another variables. The first one is age with value 5, and another one is integer variable I with the value -10. And the result is 20. The right shift operator for the same values, 5 and -10, is no, for the value I, that is -10, is -3. The next one is unsigned shift operator. And if we apply this operator to the variable I, then we will receive this value as a result. Then next, so we'll comment out our print line statements so that we have only relevant statements that we will print out next. So the next part are logical operators, and these are operators that use Boolean values. So we declare and assign now, initialize now two variables of Boolean type. First one Boolean A, that is equal to true, and next one is Boolean B, that is equals to false. The first operator is conditional AND. We use our system out print line statement again to show us quickly the result of the operation AND. And we want to have the result of A and B that equals to the operation A and B. And this is false. The next one is conditional conditional OR, and I will copy the statement to save our time. If we execute it, we see the result of the operation A or B, true or false. The result is true. Next one is logical XOR. That looks in this way. And when we execute it, we have the result. And with the last one is unary operator not A, and the result of the operator operation not B is not A not true is false, and not B not false is true. And the last type of operators are relational operators. Integer j is our first variable that we will use with the value 5. integer k with value 7 and integer L with the value 5. So the first operator is greater than, and if we want to see whether j is greater than k, we see that this is false because 5 is not greater than 7. Next one is greater than or equals. And the result of this operation is false. And in order to save our time, I will just copy here all other operations that are less than or equals, equal, not equal. And we see now that, for example, where did we stop? Here, less than. The result is true. Less than or equals true. Equals, this one is true, and not equal is also true. This was the section operators.